Good afternoon, morning, evening, wherever you are. I was asked to present you a little bit about sustainable infrastructure and the leverage of space technology. Now, you can talk about sustainable in many different ways, but I'm taking the approach of climate change and the risk and resilience on infrastructure. And hopefully it's interesting. So who am I? I studied photonics and image recognition a very long time ago. I did my internship and my thesis in the European Space Agency. That became my passion. I did not get to work in it. I worked for these companies over 28 years. IBM Energy is RWE. That's one of the largest energy companies. And now 5 years with Royal Haskoning. And my passion is understanding the market needs, applying new technology and developing new products and services. And I love to work with startups and other new businesses. A little bit about Royal Haskoning DHV. So an engineering company, 140 years in business. We design physical infrastructure. We design stuff like airports and rail and tunnels and whatever. We design business processes like supply chains, passenger flows, traffic flows, water flows. And we look at the impact that they have on the planet. And we look at how the planet and the weather has an impact on these first two. And by understanding how the facilities and processes are exposed to climate and weather events, we can help our customers to become more resilient to these events. And nobody needs to explain that over the last 3 years, what's going on. So our societies and economies are dependent on infrastructure. And that's a changing thing. There's so many challenges going on, from the aging workforce to trade wars, to depleting resources, over-optimized supply chains, changing supply chains. We have climate change, we have environmental collapse, and it doesn't stop there. So we are really in need of making these infrastructures resilient. And just to give you a view on the size of the disruptions that are going on, this is a slide from Maersk, so the big container shipping company. In 1.5 years after COVID, they had 24, 26 events that disrupted their business. And that just gives you an indication of how turmoil the whole economic situation has become. Now, we're not going into that part. We're going into the climate part, which is having a bigger and bigger impact on businesses worldwide and economies. And I often have to explain this, that climate is the long-term trends in the weather, and the weather is the short-term version of that. But people often ask, is the current weather today a result of climate change? You cannot say that, but you can say that certain trends are the result of climate change. And although there are still people doubting that, it's clear where we're heading. On the extreme weather event last week in Germany, the scientists made another statement. They said that mankind has wasted its opportunity to keep climate change a controllable event, and that we're now entering the era of uncontrolled weather situations, which is very disturbing, but it is what it is, and therefore we need all the help to be able to identify where the risks are. Now, there's two sides of climate change. There's the mitigation part. That's how do we reduce the impact that we all have on the environment and on the planet? And there's the other side, the adaptation. The planet is changing. And even if we would stop all the carbon emissions today, the weather will continue to change for the next 100, 200 years. And it will become more extreme and will more frequently extreme. So even though we still need to do the mitigation part, and it's extremely important, we also need to prepare to adapt to a changing situation. And that's the rest of the story. So physical risks from climate change, droughts, flooding, sea level rise, they have an impact on supply chains. They have an impact on where goods are produced. Will India and Bangladesh still be able to produce cotton in the future, or should we change in Europe and the US to wood fibers or other types of sources? There's changes in demands for products and services. Will the Mediterranean become too hot for tourism to go there in the peak time of summer? And will we therefore see a shift to the more cooler parts of Europe? And that comes along with a change in demand of products and services. But in the end, it's all a financial impact on an organization. Now, the mitigation part, reducing the impact, that's controlled through financial disclosures of companies. So they're measured if they're actually doing an energy transition, moving away from fossil fuel, biodiversity, sustainability, they're all part of that element. But the upper part, the one that we're talking about, is if you understand where you are exposed to all these extreme events, physical risk, then you can take certain measures. And by taking these measures, you increase your resilience to these events in the future. And that's the difference between mitigation, adaptation, and climate resilience. And resilience starts with understanding your risk. Now, climate change leads to higher temperatures. It leads to shifting climate zones, changing weather patterns. And traditionally, the whole focus of many different organizations has been on the hazard forecasting and the hazard identification. So how often will certain flood events happen? Will they happen once every 200 years, or now maybe quicker? Will a storm event happen every 30 years, but now in every 10 years? And that's been the traditional risk event, but that's not what a business needs to know. In the end, it's only the start to understanding what's my impact on my business if these events happen. Will there be water available if I'm a beer brewer in certain parts of the world? Can I still produce food? How will diseases evolve? Are my employees at risk from heat waves and stuff like that? So that's a shift in the risk business going on, where a lot of science is needed, because the impacts even today are not really good understood. Now then there's something like sectoral vulnerability, and this is where infrastructure comes into play. We think about climate change, about heat events. Just look at Europe over the last months. Heat events have an impact, but in hot parts of the world, like in Africa or the Middle East, they know how to deal with it. So airports, for instance, they have people on the platform who wear cooling vests. And they have longer runways, because the effect of hot air is that air gets thinner and airplanes have less lift. So therefore the runway needs to be longer. But the same heat event, if it happens in the UK or in the Netherlands or in Western Europe, the airports cannot deal with it. First of all, the employees of the platform don't have these cooling vests. The runways cannot be extended. It takes about 10 years to get the permits and to actually build a longer runway. So all these things have an effect on each other. And last year in the UK, 4 airports had to be closed down because of too hot temperatures. It has an effect on the runways. If the runways are made of tarmac, then if it's 38 degrees, tarmac is black. It heats up to 60, 70 degrees Celsius if there's a clear blue sky. And as a result, it gets soft. And if you then land an airplane on the tarmac, on the runway, it deforms and you have very expensive repairs to do. But it's not only the heat, it's also extreme cold. So that second picture is a telco tower. They're not designed to have this much ice on them. So it's not only the heat, but it's also other extremes. If you look at the Alps, the snowfall. It's getting less and less. It's unsustainable to have the amount of skiing resorts in the Alps because, yeah, the snow is not there. And the alternative, artificial snow, is also unsustainable. But it also has an effect on the rivers. The River Rhine was at an extreme low again last summer. And last year, there was an 8 billion euro impact on the German economy as a result of the low water level in the Rhine. So ships can take less cargo up and down. Tourism ships even have to switch between different ships who cannot get past the part of the Rhine in Germany where it's only 76 centimeters deep. So they have to come up with touring cars to replace the travel. We see the rail networks, if it's getting too hot, they bend because they expand. We see businesses who traditionally said, can you do a risk assessment on climate change and weather, but you don't have to look at my energy provisioning because I have contracts with my energy provider that they will be able to provide extra energy in times of crisis. And if they can't, there is a fine for them to pay me out. But last year in Mexico, the largest reservoir was at 3% full, and that prevented one of the largest steel companies in South America to actually produce steel because there was no alternative energy provisioning. And this is what McKinsey has been saying for 2 years now. Businesses need to start at the systemic risk and move beyond just looking at their own facilities. So they also need to take into account energy provisioning, water provisioning, the availability of personnel. And this is really the challenge that infrastructure is facing as a result of weather and climate. Now, the space data has greatly helped to do all kinds of large-scale infrastructure assessments. So we're able to track, like many others, hundreds of thousands and millions of objects in the world on 17 different natural hazards. But that has always been based on historic data. And so, for instance, this picture is an interesting one. That's Ho Chi Minh. You can see where it's subsiding over 10, 20, 30 years. It's also subject to flooding because the rain basically follows the terrain. So this was what could be done. But by now, the new space technology is providing more and more and more data, which is getting impossible to digest for scientists and others to come up with new conclusions. So there's also a new technology coming around, which is AI. So one of the things that we see happening, large language models, of which ChatGPT is the best known example. They're an example of a foundation model, and there's all kinds of tech companies, in this case, IBM, and they're taking in the Sentinel data and other data, either the satellite ones, which are 3 terabytes a day, and then they take several years of this data, and they try to train what's called a foundation model to digest these enormous amounts of data, and out of that data, they're then trying to come up with how's the land use changing, how's the biomass changing, flood and fire mapping. The same thing they're now doing on weather data, which is 100 times larger. Can you do outage predictions for energy companies? Can you do improved weather forecasting? And that's all part of a generative AI approach. So again, space data is feeding this, but it's leading to a different kind of image processing and data processing than in the past. And all these things are relevant to what we need to do in order to make businesses and economies safe and resilient from climate change. So, very briefly, our societies depend on infrastructure. The infrastructure is at risk from climate change. Space technology can help identify those risks, but the risk only on selected facilities is not enough. We need a systemic business impact view. When the risks are clear, businesses can take measures which makes them more resilient to these events in the future and keep our economies running. And AI is the exciting new field in this domain. And with that, I would like to thank you for your attention.